Welcome back. The next thing we're going to do is quite important here. Actually, it's very important. It's generally very important when one is doing variable selection, and that is to tell R to fail if the dataset contains NAs. The way we can do that is we put options na.action equals na fail. So I ran that. Let's comment this code a bit. Read in data, set na action to fail. Now this is a kind of protecting us from doing something really bad. From really bad things happening. I actually once did have an experience where I was doing model selection, forgot to set na.action equals na.fail, and spent a couple of days trying to figure out why the results were nonsense. So what this protects us against is some of the observations in the dataset containing NA in some variables and others not containing NA. If that's the case, if we've got some NAs distributed around in our dataset, what we can accidentally end up doing is fitting and comparing models with different numbers of observations, and that is actually relatively kind of nonsense thing to do. So it's a good idea to always put options na.action equals na fail when we know we're going to be doing some model selection. Good. Next step is we're just gonna make things a bit easier for ourselves by only keeping the variables that we want in our model. Keep only desired variables. We do that with the select function of dplyr, and we're going to keep body fat, age, weight, height, BMI, neck, circumference, chest, abdomen, hip, thigh, knee, ankle, and bicep. It may actually have been more efficient to say what we didn't want to keep by doing minus those. But we've written it all out now. Let's just go with that. Check, see if it runs. Error in select. I have probably got a typo in there. I'm going to pause this and just find where the typo is and come back. Well, it turns out I had typed everything correctly. It's just the wrong version of select that's being used. I want the select that's specific to dplyr. So I'm going to type this and say, please use the dplyr select. Let's run everything. Good. Now I've got DD with 243 observations and 13 variables. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. Good. The next thing for us to do is actually fit what's called the full model. Let's start our variable selection exercise with the full model. Now the full model is the one with the response variable and every other available variable as the explanatory variable. Let's call that model M1, fit it with the LM body fat as a function of, now we put dot here, so everything else, when we write dot on the right hand side of this formula, it means everything else, every other variable part that's in the data set, not body fat. So it's going to put all of these variables in as explanatory variables, and then we give the data set. We're using LM, and so all of those assumptions that we usually make with LM are made here as well. So let's run that. No errors, so good news. And as Steffi talked about, we're going to use the Eki information criteria to assess the predictive power of the models, the balance between how well they represent the data, those explanatory variables represent the data, and the number of variables. If we have lots and lots of variables, we can explain a lot of the variation, but only by chance. So we use a function called AICC. This is the small dataset correction. That little c is for correction. And we do M1. This should give us the AICC of that model. There we go, 114. That's our starting point here. Just because we said we'd start with all of the variables in the model, we could have started with none of the variables in the model and then worked up and grew a model rather than kind of what we're doing here, which is trimming down a model. But this is what we've decided to do. Good. The next thing we're going to do is use a nice function called drop term. It's in the maths package, which we loaded. We're going to do drop term on this model M1. We're going to use that, use all of the variables that are currently in M1. Oh, sorry, that's wrong. Not that. All we're going to write here is sorted equals true. So what this function does, drop term does, is it takes the model M1 and then fits a new model with one of the terms, that is, for example, with age removed from the model, and saves the results. Then it also fits a model with just weight removed and saves that model, and another model with just height removed. So it will actually create 13 models, this drop term, 13 models. And each of those models is going to have one of these explanatory variables missing. And it's going to give us the results sorted. So let's run that and see what it gave us. Well, it says it's doing single term deletions, single variable deletions. Here is the model that we started with. That's the full model, that's what we specified. And sorted here is the model with knee dropped. Knee is at the top because it's got the lowest AIC. So it's kind of like the best model among all of these models. And so this row here, knee, is this model, but not including knee. So without that knee variable, we gain 1 degree of freedom for error because we've removed a variable. Here is the difference in sum of squares, not a very big increase in unexplained variation in the model. And there's the AIC. This is the half of the AIC that we previously got. So we need to multiply this by 2, 719 multiplied by 2. I should be able to do that in my head, but now I've got 1,438. This is the AIC. This is not the corrected AIC, so we can't directly compare this value to this one, but we can compare within here. So we've got each of the models with a term dropped. Now what we're going to do is actually remove the knee variable. It was explaining least variation, so we're going to remove that variable from the model. We're going to remove that ourselves using a function called update. So we'll create a new variable. Let's call this drop term 1. update, using the function update, we're going to update M1, and we're going to keep everything. That's what that says. Apart from, we're going to take away the knee variable. Let's run that. And now we do AICC DT1. Alright, so now we have a corrected AIC of about 114. And before that, here we see the AIC of M1 is exactly the same. We need to check that we've not made a mistake and kept, well, we need to check that the actual update has worked. What I'm going to do is copy that line 24, the drop term line, put it down here and adjust it so now it's looking at DT1. Run that. We should not see knee here. Oh, we do see it, so that's not actually worked. Let me just pause this and find out why. Okay, the reason is this comma in here. That should not be there. Let's run that. Run that again. Okay, now we see a different AIC. Good. When we run this, we don't see knee in the model. So it's successfully been removed. And if we just get these two AICs, one for the full model, that's M1, and one for the DT1 with knee removed, we can see that removing the knee variable has reduced the AIC by about 2 units. Reduction in AIC means the model is going to be a better predictive model, and each variable contributes about 2 units exactly 2 units of AIC. And so by removing this variable, we've done exactly what we would imagine to happen if the variable was completely unimportant. That's the AIC is improved by about 2 units. Good. Let's take a break. After the break, we'll go through removing all the other variables and see what happens to the AIC.